Hello everyone, hope you are doing well. Welcome to the online platform Civil Techno Bricks. Guys, here we will tune for instantaneous decoding of conceptual knowledge in the field of civil engineering, where study elaborates decoding the earth to build a better world. Today we will learn the core concepts of earthquakes, causes, prevention, and its mitigation in view of civil engineering and its application. So, what is meant by the mechanism of rupture? An earthquake is the vibration produced by the rapid release of strain energy, which is the definition or technical term of earthquake. So, rock accumulate elastic strain until strength is exceeded, causing brittle failure, just shown in that picture. So, original state of rock, strain accumulation in the rock, and rupture in the rock, that is elastic rebound. These are three phases, or we can say the transformation of original rock to the rupture, or original tectonic plates to the displacement. So earthquakes are the sudden vibrations of the earth which caused by release of stored energy. That earthquakes are one of the most destructive natural geological hazards, where the seismic activity affects buildings, dams, bridges, tunnels, transportation, or we can say that on the earth surface. So earthquake study is important for safe engineering planning and construction activities. The engineers use geological knowledge to reduce structural damage during the earthquakes. So the mechanism of rupture responsible for earthquake generation, where the rocks inside the earth crust accumulate elastic strain energy due to tectonic stresses. The original stable state or the original tectonic plates before deformation begins along the fault line, which is shown in the picture 1. The strain accumulation, where rocks bend and store energy under compressive or shear stresses. Now, owing to that strain accumulation, the excessive stress causes brittle failure and sudden rupture of rocks. That elastic rebound, where displaced rock snap back and fro and release seismic waves, or we can say that to and fro or upward and downward movement. So that concludes the rapid release of strain energy which produces an earthquake, or we can say that the shaking of tectonic plates. The rock snap back to an unstrained position, releasing energy as seismic waves. That seismic waves are absorbed or affected that tectonic plates, where the global stress engine, which is the origin of the tectonic plates. So interplate activity with respect to that tectonic plates is that the friction. So friction between converging lithospheric plates generates immense stress or maximum stress. So the Benef zone represents the plane of Focky dipping beneath the continent or beneath the hard rock layers. So the planes of tectonic plates, or we can say that the plate tectonics as the primary mechanism behind earthquake, where the earth crust is divided into several tectonic plates. With reference to that tectonic plates, the convergent boundaries are marked, and that boundaries where plates collide and generate intense earthquake. Divergent boundaries where plates move apart causing crystal fracture. The transform boundaries where plates slide past one another along faults. So these are the types of divergent boundaries, transform boundaries, convergent boundaries, where the tectonic plate movement will be monitored or will be seen. So the stress accumulation along that plate boundaries results in seismic activity which causes the earthquake within the tectonic plate movement. That concludes the most important point, that most of the earthquakes occur near tectonic plate margins, or we can say that the separation. So introduce the major causes responsible for an earthquake occurrence are the tectonic earthquakes caused by movement of lithospheric plates. Lithospheric plates. The volcanic earthquake generated during volcanic eruption and magma movement, which explain the collapse of earthquakes caused by the cave collapse or underground mining activities. Reservoir induced seismicity produced due to the large dam reservoirs. which makes the settlement in the tectonic plates or which impact the stress on the tectonic plates. Human induced earthquakes caused by blasting, drilling, and underground explosives activity for the tunneling purpose or for the well excavation purpose. So that concludes the tectonic origins, which is the global stress engine, where the tectonic plate movement is the most common point and the powerful earthquake source with reference to that internal natural forces or the external man-made activities. Here the geometry of the event, which is dependent on the 2 points where focus is there and second point is the epicenter is there. Also third point is displayed, that is a fault plane basically. So with reference to that fault plane, we have to mark the focus and epicenter. Focus is nothing but a hypocenter, the point of rupture initiation within the crust 0 to 700 kilometer depth from the earth's surface, 0 to 700 maximum kilometer length, which is the hypocenter, or we can say that the focus point. Secondly, the epicenter, which is the point on the surface vertically above the focus. Epicenter is the exact vertical point above to the focus with reference to that fault plane. So the term focus and epicenter related to the earthquakes, whereas the focus is the actual point inside the earth where rupture begins, and the epicenter as the point directly above the focus on the earth's surface. The seismic energy travels outward from the focus in all directions. I repeat, seismic energy travels outward from the focus in all directions, where the damage intensity is usually maximum near the epicenter. Damage density is maximum near to that epicenter, which is on the surface of the earth, which mentions that the focus depth influences the severity of ground shaking or the ground vibrations, which concludes that the shallow focus earthquakes are generally more destructive. Now, propagation of the waves, just like seismic waves, which are most responsible for the vibration or the earthquake point of view, there are three types: P waves, or we can say that primary waves, S waves, secondary waves, and third one, surface waves. So each wave is represented with reference to that images and their direction of acting the forces or the movement. So P waves or primary waves are longitudinal, or we can say that push pull motion. They are fastest and travels through solids and fluids within the earth surface. Secondary waves, S waves, are the transverse and shear motion, just like the slower waves which only transfer or which only travel from the solids only. And the third one, surface waves, they are complex in motion. They have the slowest velocity but highest amplitude, and they are more dangerous, most destructive. So most of the collapse or damages will be seen on the surface of the earth due to that surface waves only. So the seismic waves generated during earthquakes: primary waves, secondary waves, and surface waves. So surface waves are the most destructive waves affecting structures, which mention the responsibility of the severe ground shaking, which conclude that the seismic wave behavior helps the scientists to study the earth's interior structure before the earthquake and after the earthquake, so that we can study the actual damages occurred due to that earthquake. Quantifying the event. Quantifying the event means we have to measure the earthquake based on the magnitude and intensity. Magnitude is the Richter oblique movement and intensity is by Mercalli. So with reference to that magnitude, which is defined by the Richter, where movement is stress quantitatively, which measure of energy release, or we can say that we can measure the release energy with reference to that logarithmic scale, where the fixed value per event is noted. At the second part, intensity of that earthquake, which is a qualitative measure of observed effect, which varies by distance and soil conditions, which is a subjective assessment. So these two pictures itself explain the actual quantifying the event procedure. The introduced earthquake measurement techniques are dependent on the seismology only. Seismology is based on the seismic waves study and behavior, which explains the use of seismographs, for recording seismic vibrations. Richter magnitude discuss the scale used to measure earthquake magnitude. That magnitude represents the energy released during rupture. Mercalli intensity scale describes the use of measuring damage intensity, which mentions the intensity dependent on the location, geology, and construction quality. Here, both conclude that magnitude and intensity are the important for the earthquake assessment. If we have to classify the earthquake with reference to that origin point of view, then there are four topics, or we can say that parts. First is a tectonic, just like primary, within the plates of the rock. Volcanic, due to the molten magma eruption. Third one is a collapse due to the failure of roofs or failure of rock tectons or plates. And fourth one is the anthropogenic, which is the man-made activity, we can say that. So the major effects caused by earthquake on society and infrastructure are dependent on the structural damage due to the building, bridges, roads and dams. The ground shaking and surface rupture along the fault zones mentions landslides and slope failures triggered by seismic vibrations. Third part is the liquefaction, where water saturated soil loses strength during the shaking, which creates the tsunamis generated due to the underwater earthquakes. Here we conclude the earthquakes can cause both direct destruction and secondary hazards too. Here one of the example of structural dynamics and inertial forces. Here the existing building is changing their shape above the earth's surface due to that ground acceleration with reference to the direction. So shear stresses are applying with reference to the foundation or with reference to the plinth level in upward and downward direction. At the same time, the inertial forces are applying at the center of gravity of the building in upward direction also and in horizontal movement also. So inertia, resonance and failure modes, these are the three main points which are most important to study with reference to the structural dynamics. So that inertia is the ground accelerations where building mass remains at rest. Resonance is nothing but a damage maximizes when ground wave period matches structural natural period. And at third, failure modes, where column, beam, these are the structural members of the building. So here failure modes are column shearing, then ponding and soft story collapse. This is the actual structural dynamics and inertial forces which are studied or focused for the sake of the assessment of after earthquake damage or during the earthquake movement in between the existing structures. Here soil failure due to the liquefaction. So what do you mean by liquefaction? Liquefaction is the actual activity or role of the underground water through the seepage or through the percolation from the any reservoir, just like dams. So here the process is itself said that the saturated cohesionless soil lose effective stress during shaking and behaving like a dense fluid. So heavy structures sink during that dense fluid which are buried infrastructure floats. Just like in Himalaya or in Uttarakhand, landslides are there. With respect to landslides, liquefaction activity, large amount of damages to the structural are noted. So in liquefaction as a major geotechnical effect of earthquake, which explains that the loose saturated soil behaves like liquid during intense shaking, which shows the loosen in the soil strength and bearing capacity, huge amount of damage will occur. The settlement and tilting of structures due to the gravity or due to the ground instability explains that the sand balls and lateral spreading commonly observed during liquefaction. The coastal and riverbank areas are more prone to the liquefaction activity, or we can say that liquefaction failure. So that soil failure through the liquefaction will be concluded that the soil investigation is essential before the construction in seismic zones. So we have to follow the guidelines for the soil investigation before starting the construction for that area where we have to plan, where we have to execute our plan. So cyclic loading plus saturation is equal to zero shear strength. So when the tectonic plates are in the shaking motion, that shaking impacts on the loose soil and water. That water and loose soil may be converted in the dense fluid, and this dense fluid is flowing through the foundation, which impacts on the structures, or the impacts on the foundation of the structures. This is the actual impact of liquefaction. Here, surface hazards, rupture versus shaking. So fault rupture is the first image and ground shaking is another second image. So ground shaking is based on the time versus acceleration. That time is in seconds. Here, most important point is the duration and the amplitude. So the center point, with reference to the center point, there will be a sinusoidal wave which shows the peak ground acceleration at what time and with what amplitude. So vibrational energy measured in peak ground acceleration, the primary cause of wind spread damage. And the fault rupture is the first image where the n number of tectonic plates are there, alluvium, bedrock, likewise. Then with reference to that fault gauge, the equal and opposite forces are applying, and it gives the fault scrap, which is a vertical offset at the upward side, and we get the fault gauge at the bottom side. So physical ground displacement is noted with reference to that fault rupture, where immediate destruction of trading structure will be occurred. So what are the principles of earthquake resistance design? So we have to prepare our structural design with reference to that earthquake resistant structure. So earthquake resistant structure is most important for the disaster management point of view. The disaster management practices followed during earthquake emergencies, which explains preparedness activities such as evacuation planning and mock drills, which discuss early warning systems and seismic monitoring networks. The rescue operations and emergency medical support after earthquake also provided the rehabilitation and reconstruction of damaged infrastructures. So shear walls, cross bracing, brace isolator, these are all the earthquake resistant structure components which are introduced nowadays at the execution phase of any structural building, so that shear walls for the solid concrete panels, cross bracings, X-shaped steel members, and brace isolators, they are the pads between the foundation and the columns. So ductility, configuration, and isolation, these are three phenomena. Ductility, which is the ability to deform without brittle fracture. Configuration, symmetry avoids torsional stress. And isolation, decoupling superstructure from ground motion. So isolators provide the decoupling, means they can neglect the contact of whole building to the ground surface, and that isolators plays the role of just like bearings to absorb the shocks. The rehabilitation and reconstruction of damaged infrastructure, which is the most important role of government agencies and engineering teams with reference to the recovery. So that concludes the disaster management minimizes loss of life and properties. The seismic zone and the risk assessment. So in India, how many seismic zones are there? One, two, three, four. So first is the Kutch, second is where where second is low, zone 2, third is zone 3 moderate, zone 4 high, zone 5 severe. Okay, so zone 2, zone 3, zone 5, 4 and zone 5 are there. So seismic zones with reference to that severity of that earthquake occurred earlier. Likewise, the seismic zones are divided. Zoning maps classify regions by peak ground acceleration probability. Construction codes mandate higher seismic coefficients in zone 4 and zone 5. So large amount of earthquakes will occur in the severe zone, zone 5, which is shown in the red color, northeast India and the Kutch part, zone 5. Then zone 4, which is a high, which is shown in the orange color, Jammu, Kashmir and Delhi part. Zone 3, which is a moderate yellow color, Maharashtra, Western Ghats, and zone 2, low blue color, which is a central craton. So earthquake hazard zonation used for seismic risk assessment where the regions are classified according to the expected seismic intensity. High risk seismic zones located near active tectonic boundaries. The importance of that seismic zoning map in engineering design and planning in India, which is divided into different earthquake hazard zones. So the vulnerability of Himalayan and northern eastern regions, that concludes the hazard zonation helps engineers for the safe design and safe construction activities. The disaster management strategies dependent on the disaster management cycle, pre-disaster, post-disaster and during the disaster. During the disaster, response activity is there, pre-disaster mitigation techniques are there, and post-disaster recovery is there. So the disaster management practices followed during earthquake emergencies, where preparedness activities such as evacuation planning and mock drills are monitored. Early warning systems and seismic monitoring networks, which rescue operations followed by the emergency medical support after earthquake. Rehabilitation and reconstruction of damaged infrastructure, which plays the role of government agencies and emergency teams for any type of recovery. That concludes the disaster management, which minimizes loss of life and property. So the disaster management strategy are most important point for the mitigation technique, recovery and response point of view. Stay tuned guys. Happy learning.